Welcome to All 4 C Learning. We are going to start session 4 here. So yesterday we have discussed about preparation of halogen compounds from alkenes. So normal method is completed and only halogen addition is completed. Allylic halogen is completed. For example, here compound is given like this, which is having substitution. Supposed to be here HBr is given, H2O2 or R2O2 is given, H2O2 or R2O2 is given, hydrogen peroxide is given. Again second step, here HBr is given, 500 degrees centigrade temperature is given, 500 degrees centigrade temperature is given, or 773 Kelvin temperature is given. Then what type of products are possible? Will form the same products or different products? We have to see right now. Wherever HBr, H2O2 is given, first step is, or first reaction is electrophilic addition reactions. But here medium is H2O2 is given. Peroxide is given means anti-Markovnikov product is important. Anti-Markovnikov product is important in first case. Anti-Markovnikov product means the nucleophile is added to less substituted carbon which is having more number of hydrogens. Here no hydrogen, here one hydrogen. So the bromine is added to here only. Again hydrogen is added to here only. Anti-Markovnikov product is important. Now if you go to second one HBr 500 degrees centigrade temperature is given. 500 degrees centigrade temperature is given, or N-bromosuccinamide is given, or more temperature is given. Allylic halogenation is possible. Allylic halogenation means according to a given structure, how many allylic carbons? Here 1, 2, 3. Total 3 allylic carbons are there. According to reactivity order, tertiary allylic is greater than secondary allylic is greater than primary allylic. But here primary and secondary allylic carbons are present. Then which one first priority is given to this one or this one? How to decide that one means here both are secondary allylic hydrogens, but according to IUPAC nomenclature, the first priority 1, 2, 3, 1 plus 3, 4, 1, 2, 3, 2 plus 3, 5. The first priority is given to this one. So according to IUPAC nomenclature, here 1, now here Br is given allylic halogenation. So this is the way to write that product. If you add the bromine here also doesn't matter. Both are allylic in this case. So HBr. Now next preparation method is preparation of halogen compounds from alcohols. Preparation of halogen compounds from alcohols. Alcohols means the organic compounds which are carrying OH group is called alcohols or hydroxy compounds. Then how to prepare the halogen compounds from alcohols means removal of OH group from a given compound by using halogens. By using halogens means these are carrying what type of connectivity? COH connectivity. COH connectivity means the bond undergoes heterolytic cleavage. Always the bonded electrons migrate towards more electronegative atom here. So that means here OH minus is replaced by incoming minus. Minus means nucleophile. One nucleophile is substituted by another nucleophile. That means this type of reactions are nucleophilic substitution reactions. nucleophilic substitution reactions. That means alcohols undergoes nucleophilic substitution reactions with halogens compounds from the alkyl halogen compounds. Alcohols undergoes nucleophilic substitution reactions with the halogens from the halogen compounds. Halogen compounds here. Halogen compounds. Here alcohol is given. Alcohol compound. Alcohol compound reacts with hydrogen halide compounds. Hydrogen halide compounds in the presence of dehydrating agents anhydrous ZnCl2 or concentrated H2SO4 or H3PO4. That means in the presence of dehydrating agents. What will happen in this case? The OH minus group is replaced by X. Final product is Rx plus H2O. Final product is Rx plus H2O. Formed product is alkyl halogen compounds. X is equal to chlorine or bromine or iodine here. So here Hx is given means how to write the reactivity order of the Hx. How to write the reactivity order of the Hx means the reactivity order is Hi is greater than HBr is greater than HCl is greater than HF like this. HF like this, which is good nucleophile here. I minus is good nucleophile when compared to remaining compounds. In the same way, how to write the reactivity order of the given alcohols? Given alcohols means here allylic alcohols reactivity is greater than tertiary alcohols, reactivity is greater than secondary alcohols, reactivity is greater than primary alcohols. Reactivity order allylic alcohols, tertiary alcohols, secondary alcohols and primary alcohols. So here supposed to be here, for example, CH3OH is given. CH3OH is given. The compound reacts with HCl in the presence of anhydrous ZnCl2. In the presence of anhydrous ZnCl2. The OH minus is substituted by Cl. So CH3Cl plus H2O is formed in this case. H2O is formed in this case. So nucleophile OH minus nucleophile is substituted by Cl minus. That means nucleophilic substitution reactions. Majority of the primary alcohols undergoes SN2 reactions. Secondary and tertiary alcohols undergoes SN1 reactions. But according to theory, SN2, SN1. But whatever compound is given, then how to explain the given reaction is SN1 or SN2 means mainly depends on the given reactant structure. Maybe rearrangement is possible. Maybe rearrangement is possible means most of the cases reactions are SN1 reactions. We will discuss that SN1 and SN2 properties reactions in alkyl halogen compound properties. Now here CH3OH OH group is replaced by Cl means CH3Cl is formed here. Primary preparation of alkyl chloride compounds. Preparation of alkyl chloride compounds from primary and secondary alcohols. Primary and secondary alcohols method is generally called Groove's method. Groove's method. Preparation of alkyl chloride compounds from primary secondary alcohols is generally called what? Groove's method here. So HCl and ZnCl2. HCl plus ZnCl2. 1:1 ratio is generally called Lucas reagent. Lucas reagent here. When compared to tertiary alcohols, primary and secondary alcohols reactivity is less. Due to that reason, in the presence of mixture, the molecule undergoes nucleophilic substitution reaction. But wherever tertiary alcohol is given, tertiary alcohol reactivity is somewhat more. Somewhat more means without ZnCl2 also the molecule undergoes nucleophilic substitution reaction. That means tertiary halogen is replaced by given halogen. Tertiary hydroxy group is replaced by given halogen here. So, for example, here CH3 is given, again CH3 is given, CH3 is given, OH is given. Here HCl, hydrochloric acid, hydrobromic acid. Given reactant is tertiary alcohol. What I told you right now, tertiary alcohol reactivity more. Due to that reason, in the absence of ZnCl2 also reaction is possible here. The OH group is replaced by Cl. The OH group is replaced by Cl here. CH3 Cl. CH3 Cl here. So this is a way to write the products in this case. So finally the reactivity order means tertiary is greater than, secondary is greater than, and primary compounds. So when you write the mechanism, such type of example is given. Based on the structure we can write that one. Based on the structure we can write that one here. That means given compound having primary or secondary OH groups, but adjacent carbons are having tertiary nature. Tertiary nature. The type of molecule is given, rearrangement is also possible. For example, here CH3 is given, again CH3 is given, here iodine is given, here CS2 is given, CS2 is given, here CS2 OH is given, CS2 OH is given, CS2 OH is given, CS2 OH is given. Again reaction with hydrochloric acid. Reaction with hydrochloric acid means what type of cleavage is possible? H plus and Cl minus. Here protonated donor is there. That means OH group is very bad leaving group. How to convert the good leaving group? By the addition of H plus. That means which one donor? Oxygen is donor here, H plus. The lone pair electron migrate towards H plus. Then form the CH3 here. Again CH3, again CH2 OH plus. Due to the presence of opposite charge, again the oxygen is having 3 bonds. Then stability is very less, act as a good leaving group in this case. The sigma bond electron migrate towards oxygen. Then removal of water. Form the here carbocation CH2 plus. Now the formed carbocation is primary carbocation. That adjacent carbon has tertiary nature. Then rearrangement is possible here. So hydrogen migrate toward this one. Then form the here CH3 group, again CH3, again CH3 here plus. Primary carbocation converted to what? Tertiary carbocation. Tertiary is more stable. Tertiary is more stable. Then the product is, final product is addition of nucleophile. Addition of nucleophile. Here CH3 group, again CH3 group, again CH3. The nucleophile is added to C place, then form the product. This is the way to write that product wherever this type of molecules is given. Wherever this type of molecule is given. For example here, cyclic compound is given, supposed to be a CS2OH. CS2OH. Given compound is primary compound. Given compound is primary compound. Again reacts with HCl. Again reacts with HCl means H plus is electrophile, Cl minus is nucleophile. Again the lone pair electrons donate to the H plus. Then the the OH group convert into H2O. OH minus is very bad leaving group. Whenever add the H plus to OH group, it convert into good leaving group. Now removal of H2O. Form the carbocation. But formed carbocation is primary. Again the 5-member ring is having primary neck. The 5-member connected carbon having primary carbon. Already I told you, according to cycloalkane stability order, cyclohexane is more stable when compared to cyclopentane. Wherever ring connected carbon having positive charge, ring expansion is possible. So supposed to be here 1, 2, 3, 4, 5. First carbon, fifth carbon, sigma bond electron migrate towards positive carbon. Here. Positive carbon. Then the 5-member ring convert into what? 6-member ring. Here 1, 2, 3, 4, 5, 6. Which bonded electron migrate towards C plus? Fifth carbon, first carbon, sigma bond electron migrate towards CH2 plus. New sigma bond is formed in between the fifth carbon and sixth carbon. Which is going to lose the electrons here? First carbon. Then the first carbon gains positive charge. So final step is nucleophile attacking step. Form the chlorocyclohexane. So many examples are there. Wherever example is given, reactant is given, based on the group positions, we have to write the products. This is the way to write that ring expansion. Simple molecule is given. This is the way to write the migrated product. Hydrogen shift from tertiary carbon to primary carbon, then form the product like this. So ring type compound is given or cycloalkanes is given. Based on the example, we have to write the final product here. So based on the examples, we can write product here. Now preparation of alkyl halogen compounds from alcohols, again by using phosphorus halides. For example, here CH3OH is given or CH3CH2OH is given. Ethyl alcohol is given or methyl alcohol is given, doesn't matter. Supposed to be the compound reacts with HCl plus anhydrous ZnCl2 is given. Then what type of reaction is possible? OH minus is replaced by Cl. Nucleophilic substitution reaction. CH3CH2Cl. Cl is given. Supposed to be, sometimes they will give you HCl temperature. Here also same thing, we will write product like this CH2Cl. CH2Cl is given. CH2Cl. For example, here phosphorus halide is given, PCl3. Phosphorus pentachloride is given. Phosphorus pentachloride is given means here also same thing, OH minus is replaced by Cl minus. Here also same thing, OH minus group is substituted by Cl here. That means formed product is alkyl halide CH3CH2Cl. Again, how many chlorines? Remaining chlorines, total number of chlorines 5 here. One is here, remaining 4. Remaining 4 means one that react with H, form the HCl. Again, remaining oxygen and PCl3, POCl3, phosphorus oxytrichloride. Phosphorus oxytrichloride here, which is having sp3 hybridization nature. So, phosphorus pentachloride. For example, here PCl3 is given, PCl5 is given or PCl3 is given, doesn't matter, form the halogenated product, but byproducts are different here. Byproducts are different here. Here OH minus is substituted by what? Cl. CH3CH2Cl here. CH3CH2Cl here. But byproduct is H3PO3, you remember. H3PO3, you remember here. Then how to write the means? Here CH3CH2OH. How many moles required means 3 moles alcohol required in this case. That means whenever alcohol reacts with phosphorus trichloride, 3 moles of alcohol is required. So 3 moles plus 1 mole of phosphorus trichloride. Now how many OH groups? 3 OH groups. 3 OH groups. That 3 OH groups are substituted by what? 3 chlorines. 3 chlorines. So that means 3 moles CH3CH2Cl. Remaining how many hydrogens? 3 hydrogens. Remaining how many oxygens? 3 oxygens. Remaining how many phosphorus atoms? 1 here. H3PO3. H3PO3 here. That means 1 mole phosphorus trichloride reacts with 3 moles of alcohol, form the 3 moles of alkyl chloride. 1 mole phosphorus pentachloride react with how many moles of alcohol? 1 mole of alcohol here. 1 mole of alcohol. They will ask you questions on this concept somewhat different. Sometimes they will ask you ratio of alkyl halides, ratio of PCl5 and PCl3. 1:1 ratio of PCl5 and PCl3 reacts with X moles of alcohol, then form the alkyl chloride. How many moles X is equal? With PCl3 3 plus with PCl5 1, 3 plus 1 4 moles, like this. So PCl3. Next one is phosphorus plus bromine. Phosphorus plus bromine, red phosphorus, nothing but form the PBr3 again. PBr3 again here. That means 2 moles phosphorus plus 3 moles bromine. Form the phosphorus tribromide. Phosphorus tribromide here. So red phosphorus with the bromine halogen combination form the reagent. So here also same thing. The OH group is substituted by what? Br. Br here. Form the product. Here CH3 again CH2 Br. Br. That means alkyl bromide is formed in this case. Again phosphorus plus I2. Phosphorus plus I2, nothing but Pi3, you remember always. In the same way, 2 moles phosphorus react with 3 moles of iodine, form the 3I3 like this. Instead of bromine, if you take iodine, form the Pi3. Same thing here. Again, which is nucleophile here? I. OH minus is substituted by what? I here. So now CH3 CH2I. CH3 CH2I here. Again, for example, here CH3 is given, here CH2 OH is given, compound reacts with KBr in the presence of H2SO4, H2SO4, H2SO4. OH minus is substituted by what? Br. Final product is CH3CH2Br, CH3CH2Br plus KHSO4, 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 H plus OH minus plus H2O. By using the potassium bromide in the presence of sulfuric acid, concentrated sulfuric acid, form the alkyl bromide compound. In the same way, we can prepare alkyl iodide also. For example, here alcohol is given, compound reacts with potassium iodide plus concentrated H3PO4 is given, concentrated H3PO4. So here also same thing, OH minus is substituted by I here, formed product is alkyl iodide. Again H is replaced by means nothing but H and OH, H2O. Again KH2PO4, KH2PO4, potassium phosphate. So by using the potassium iodide also we can prepare alkyl iodide here, alkyl iodide. This is the way to prepare the alkyl halogen compounds from phosphorus. By using phosphorus halides we can prepare halogen compounds, here. Again Doujins reaction. By using the sulfur oxychloride we can prepare halogen compounds. For example, here alcohol is given OH group, alcohol compound reacts with SOCl2 in the presence of pyridine molecule or pyridine medium or inert medium. So which is replaced by OH group? OH group is replaced by Cl. OH group is replaced by Cl or Cl. OH group is replaced by Cl or Cl. Remaining how many oxygens? 1. Here how many oxygens? 1. Form the sulfur dioxide. Remaining how many halogens? Here 1. Remaining how many hydrogens? Here 1. HCl. Hydrochloric acid. That means alcohols reacts with thionyl chloride SOCl2 in the presence of pyridine medium or ether medium, form the alkyl halogen compounds or alkyl chloride compounds are called Doujins reaction. One of the best method to prepare the alkyl chloride compounds. Why one of the best method this one? Remaining whatever method is given, somewhat byproducts are formed. To remove of that byproducts somewhat difficult. That means we will get less amount of yield. Wherever this reaction is given, byproducts formed in the gas state. Formed in the gas state means we can remove easily from that mixture. Due to that reason, one of the better reagent to prepare alkyl chlorides from alcohols. Which one? SOCl2. By using this reaction, we cannot prepare alkyl iodides and alkyl bromides. Why? Because SOBr2, SOI2 is not possible. Due to that reason, we will prepare only alkyl chlorides. This type of reactions are generally called what? Doujins reactions. For example, here CS is given, CS2OH is given. Now sulfur oxydichloride, thionyl chloride, sulfur oxydichloride medium is given. which is replaced in this case OH minus CH3 CH2 Cl SO2 plus HCl, SO2 sulfur dioxide plus hydrochloric acid, both are formed in gaseous state. So this is a way to prepare that alkyl chlorides from alcohols. Next one is Finkelstein reaction. Finkelstein reaction means removal of alkyl halides from removal of alkyl halogen compounds from alkyl halogen only. Majority of the alkyl iodides we can prepare by using this one here. For example, alkyl chloride compound is given. Chloride compound reacts with sodium iodide in the presence of acetone medium. Which is replaced here? More electronegative group is replaced by less electronegative group. That means Ri plus NaCl. Byproduct is NaCl. So alkyl chloride compounds are alkyl bromide compounds reacts with sodium iodide in the presence of acetone medium from the alkyl iodides are called Finkelstein reaction. That means more electronegative group is replaced by less electronegative group in this case. This one also nucleophilic substitution reaction. For example, alkyl bromide is given, compound reacts with sodium iodide in the presence of acetone medium here. Br minus is substituted by what? I. So alkyl iodide plus NaBr. For example here CH3 Cl is given, NaI is given, NaI. Cl minus is substituted by what? I. Here CH3I. Majority of the reactions, Finkelstein reactions, are SN2 reactions. This one is generally called Finkelstein reaction. This one is generally called Doujins reaction. So we'll continue in next session. So thank you.